This machine does the work of several construction workers. It lays down the concrete in layers and can build 4 square meters of wall per hour. That's how Europe's largest 3D printed building is being constructed, an industrial building without windows.
Most people hear bricks and think of red rectangles stacked by hand. China hears bricks and thinks national infrastructure weaponized through engineering. What they're building isn't construction material. It's a new generation of structural technology that bends physics, speeds up megaprojects, and reshapes how cities are born. The shift starts with 3D printed composite bricks. These aren't clay. They're engineered blends of polymers, recycled aggregate, and structural fibers. Large-scale gantry printers produce them by the thousands with micron-level internal lattice patterns. Geometric cores that provide the same strength as concrete blocks while weighing up to 40% less. The result is a brick that behaves like aerospace material. Ultra-light, ultra-strong, and ridiculously fast to manufacture. But weight isn't the only trick. China's material labs have been testing thermal routing microchannels embedded inside each block. These channels capture heat during the day and release it at night, reducing HVAC load in megacities with brutal temperature swings. In short, the bricks themselves help regulate a building's climate. Then you get the headliner, Aerobricks. Imagine a brick made from aerogel, one of the lightest solids on Earth, fused with a fiber shell. These bricks offer insulation values that beat traditional materials by a factor of 4. They're fireproof up to 1,200 degrees Celsius, impermeable to moisture, and so light that a worker can stack them for hours without fatigue. For skyscraper construction, reduced weight means smaller load-bearing structures, which means cheaper, faster, taller buildings. Now add the beast of the lineup, interlocking megabricks. These are massive precast blocks shaped like high-precision puzzle pieces. Instead of mortar, they use mechanical interlocks so tight they can resist earthquakes without cracking. Robotic cranes place them using AI-guided positioning, and crews assemble building floors in hours instead of days. This tech debuted in a few pilot cities where full apartment units were snapped together like Lego on a 1-to-1 scale. China has already proven the speed potential. Remember the 10-story building assembled in 28 hours? That was the early form of this technology. The new versions use stronger carbon-reinforced composites, embedded conduit channels for wiring, and sealed thermal foam cores. And then there's the wild card, energy-retaining heat bricks. Made from modified phase change materials, these blocks store solar heat during the day and release it at night. They effectively turn entire walls to passive energy batteries. Rural regions are testing them to reduce reliance on coal heating, a major step toward cleaner energy without expensive electrical upgrades. Another upgrade hits longevity. China has become a global leader in self-healing concrete, using capsules of limestone-producing bacteria that activate when cracks appear. Now they're blending this tech into brick composites. Tiny fractures instantly trigger chemical reactions that fill gaps, adding decades to a building's lifespan. It's maintenance made automatic. Even demolition is getting an upgrade. A new class of deconstructible bricks is designed to separate cleanly for full material recycling. Buildings made from these can be taken apart instead of destroyed, recovering nearly 90% of the material for reuse. That's a huge deal in a country running through millions of tons of construction waste every year. Put it together, and China isn't just making better bricks. They're rewriting the rules of urban construction. Buildings assembled faster than paperwork can be filed. Walls that store energy and regulate their own temperature. Structures lighter, stronger, and more fireproof than anything on the market. Materials that fix themselves and can be deconstructed like modules. This is construction evolving the way smartphones did. Suddenly, aggressively, and with global impact. The future city isn't built one brick at a time, unless those bricks are operating at the level China is aiming for.